In this section, we will build functional Kotlin application. Also, we will touch design of JavaFX applications, how to separate pure functions from side effects. We will discuss various app components, and we will see how to make JavaFX, arrow, and coroutines work together. Let's go straight to the first video. High-level application design. In this video, we'll discuss what is JavaFX, how to use unidirectional data flow, and what would be our app components and how we would design it. JavaFX is a software platform for desktop and rich internet applications based on Java. JavaFX programs translates to JVM bytecode. Kotlin translates to JVM bytecode too. That's why we could use Kotlin to build JavaFX applications. We'll implement our simple app using JavaFX platform. And don't worry if you don't have previous JavaFX experience. It's not necessary for this course. Unidirectional data flow is a term to describe the principle of application design, where all data pass from one component to another in a single direction. It means that if component A passes data to a component B can't pass it back to A. This is an example of how we could design our application using unidirectional data flow. We could imagine that data flow starts from UI, and UI dispatch an action. Action goes to reducer to process this action, then result of the processing goes to store, that will store the state of our application, and store will notify a UI. And this cycle goes again and again. This is how our app will be functioning. Components of this application consist of two types of components. One component is fully functional, like action, which is immutable object, or reducer, which is pure function, and another components such as UI and store are mutable and contain side effects. And this is pretty important to separate these two types of components, so developers will know how to interact with them. UI component will represent a platform UI. In our case, it would be JavaFX. Also, UI component will contain a binder. We need a binder to decouple UI from the state of UI. It means that if we will want to use the same state for a different platform, for example, Java also supports UI based on Swing library. We could just replace a binder and application state will remain the same. This will simplify testing a lot. Action, in our case, could be enum or sealed class. It will represent user action such as button press or text entering, or external action such as response from a server. Also, using enum and sealed class will help us to make sure that reducer will process all the actions. Reducer, in our case, as I said previously, is a pure function. It will accept state and action, and based on it produce a new state that will go to store. Store will contain the actual state of application and notify UI on changes.